Welcome back to the channel. My name is Angela and we're here to apply AI to biology. So today, what we're going to focus on is this conundrum that a lot of bioinformaticians find themselves in. You are handed a data set and you are told, analyze that. And perhaps you have not even seen this sort of data before. So you're like, what do I do with this? Well, I was recently put in that sort of situation and came out of it all right. But in retrospect, now that we have access to all of these super cool AI tools, why not ease the burden for ourselves and do it a little more efficiently than weeks of consummate Google searching? So today, I'm going to lead you through how you would use Claude connectors in order to do this initial exploratory part of bioinformatics. What are Claude connectors though? Claude connectors are simply a way to connect Claude to some sort of a database or tool that will then allow you to utilize that tool with Claude acting on your behalf within the conversation that you're having with Claude, which is super convenient, and it's so nice to have everything in one place. So today I'm going to give you an example of how you do that using TCR sequencing as an example, and we will get you oriented with what Claude can do. All right, first thing we are going to do is go to claude.com/download and download Claude. We download that for Mac OS, save that as a disk image. When that's done downloading, you do the usual in opening that up, dragging it into your applications and opening from there. So we will open Claude, and wow, I'm back already, so I don't have to do any setup. I think initially you'll probably have to tell it your name and whatnot, but once you have it open, you simply go to Customize, then you go to Connectors, and there are two connectors that we want to connect now. We can browse connectors and go to Hugging Face and connect, and it will launch in a new tab so that you can authenticate like this. Go authorize, and it's connected. Okay. And connect. And connect. Okay, so those should be connected now. We can see the status here. And go here, and then I do have a prompt because we have TCR sequencing data and we want to know how we can analyze that data. So what sort of tools would be available for us is kind of the first question bioinformaticians will be thinking about, but there are a million places to look for that. You could go to Google or do a PubMed search on keywords, but then you'll come up with a lot of tools that are outdated maybe. We'll paste this in here. Basically what I'm asking it to do is that we have a bulk TCR sequencing data set and we want to analyze clonotype diversity and expansion. What tools and models are available according to literature? Use the consensus, Hugging Face, or GitHub connectors when appropriate. GitHub probably won't be of use here. Write a brief explanation for each one and then make a summary table. In the summary table, include a link of the paper on PubMed or bioRxiv, because otherwise it'll just be the consensus link, which will take you to consensus, and then you'll have to go search for the paper elsewhere, so you don't have to subscribe. We want also the year the article was published, so we know how old this tool is. A link to the tool on GitHub or Hugging Face, or some sort of documentation. And the last time the repo was updated, which is also important, it gives an indication as to how how well maintained the tool is, which is important. So you might go ahead and analyze a data set using a tool, but if you find that it's old and outdated later, then you may have to redo your analysis if you have maybe some new samples coming in, you know, the year or two after, or things like that. I want to know whether the tool is for use in R or Python, and the data type that the tool analyzes, because a lot of them are specialized for in the single cell RNA sequencing data, because a lot of people, or I guess single cell TCR-seq, and whether they do clonotype calling, expansion, or both. And then let's put it on Claude Sonnet and Medium. I find Claude Sonnet is pretty good for most things, and Medium I think is kind of gives it a little bit more thought process to this. So we'll launch and see what it does. So we can see that it's used the consensus connectors, and now it's doing a hub repo search. It's finding tools, always allow. See, it's queried TCR T-cell receptor clonotype diversity sequencing in models, datasets, and spaces. Limit to the first 10. No repositories found. So then it went and did a different search. No repositories found. Tried a different query. None found. It's doing a consensus search. And it's kind of narrating what it's doing as it goes, which is kind of cool. Oh, now it's decided it's going to make an HTML file for us and make it all pretty. All right, so it is done, and we have something we can look at here. Help out. There we go. Okay, awesome. Let's look at this super cool output that Claude made for us using these connectors. We've got MixCR tool, we've got Trust4, VDJ tools, ImmuneArc. All of those are very common tools that are used quite a lot, although it looks like VDJ tools is now a little bit depreciated, and it's really neat how Claude was able to capture that and flag that for us. And we can see also what sort of data type these types of tools process, what sort of functionality they have, and what language they're programmed in. Fantastic. So very pretty. Maybe we didn't need that much pizzazz, but it certainly is going to be a nice reference document for us when we go to do our TCR sequencing analysis. The connectors that I showed today are ones that I use quite a bit. That's Consensus and Hugging Face, but there are a lot of others. There is a PubMed one for connecting to the PubMed database. There is GitHub for connecting to GitHub repo information. Benchling, which a lot of you may know is an electronic laboratory notebook system. And many others. So I put links to some of those below, but if you can think of others that might benefit bioinformaticians or people working in life sciences, post those in the comments. I'd love to hear. So thank you for watching.